Welcome back to Disruptors Unleashed, where we explore bold, disruptive ideas and chat with the trailblazers who are redefining industries as we know them. In our previous episode, we looked at how connected solutions deliver future ready operations with Mike Bradford from Dassault Systems. Today, we are kicking off a brand new mini series featuring our very own infrastructures. The Dassault Systems infrastructures are the small but mighty engineers, builders, and designers of tomorrow who are asking the big questions like how can our infrastructure and cities change to tackle the challenges of today and tomorrow? I'd like to welcome a special guest, 9-year-old Bernardo, who's a big train fan. He'll be speaking with Muthu Sivanantham, who's one of our leading experts on the topic of logistics and rail freight. Today, they will discuss the huge sector that is logistics, and particularly, how can we decarbonize one of its most promising modes of transportation, rail freight. Over to you, Bernardo.
Hi, my name's Bernardo. What's your name?
Nice to meet you, Bernardo. My name is Muthu Sivanantham. I'm one of the industry solution leaders at Dassault Systems. I work very closely with our rail freight and logistics customers.
Hi, Muthu. I also love trains. I especially love how fast they go, but I've always wondered what makes them go so fast.
Close to 75% of freight trains that move our goods today around the world fall into this category of diesel-driven propulsion. Now, most of the real speedy ones, aerodynamically designed passenger trains that literally fly across, call it maglev, which is based on magnetic levitation. Even without the magnetic levitation, think of it like the Shinkansen or the TGV or the Eurotunnel train. Majority of them, almost all of them, are powered by electricity. And they get their energy, electrical energy, from special lines above the tracks or sometimes on the side. It's almost like plugging this entire system into a huge power wall socket. Right? And guess what? There are even newer kinds of trains joining the party, in the rail freight segment especially. Some are like giant remote control cars, and they are powered by huge batteries. And they can just run without any diesel. All they need is a very good charge. And some are even starting to use hydrogen. But these newer kinds of energy are used only, right now, unfortunately, only by the remaining 25% of the rail freight segment. Some of them, because of practical reasons, even use a combination of one or more, diesel with hydrogen and diesel with battery and so on.
So I guess it's a big challenge to make all those trains run on electricity, right?
The underlying fact is, most of the trains today are electric ready. They are electric traction ready. So they all have a smaller battery, not a huge battery, but they can be easily retrofitted. For example, the current diesel version can be retrofitted into a bigger battery version, or they can be retrofitted to add hydrogen as a fuel. And of course, it's the newer standards and technologies, they come with newer challenges too, right? We have to worry about thermal runaway, fire hazards, leave alone real high pressure. Hydrogen operates at a 700 bar, which is like a real high pressure environment. And if something happens, some untoward incident happens, they have to be really considered for battery aging, battery longevity, etc. So there are some challenges that we need to account for. Guess what? They also come with a lot of additional benefits. In addition to being less emission, less polluting, they also can conserve energy, for example, through regenerative braking. When it comes to going downhill, or whenever they brake, those energy, instead of losing them as heat, they can be put back into batteries.
Wow, that's really cool. But it also sounds super complicated. How do the train builders and operators plan to change all their trains?
That's an excellent question as well, Bernardo. As we saw, there's a huge potential to decarbonize the remaining 78% of rail freight segment that uses diesel as their primary fuel. Just to quote, this is coming from a rail industry, OEM, a diesel locomotive emits around 30,000 tons per year more carbon dioxide than its battery equivalent.
Wow, that's a lot. But I guess that's also a big opportunity for those looking to transition.
Yes, so we definitely know there's a lot of potential if we electrify the remaining 78%, right? At the same time, it is also very, very cost prohibitive. To electrify the entire North American rail freight network, it's estimated to cost somewhere more than $1 trillion. That's US dollars, that's trillion with a T, in completely new investments that have to be borne by the Class 1 railroads, the rail operators, which most of them are private companies, and they have no incentive to go spend $1 trillion in some benefits they'll get really down the lane. So these numbers, actually, these estimates are coming from AAR, that stands for American Association of Railroads. So it is literally not practical. It's very, very cost prohibitive to completely change them to electrify the network entirely. So that's why operators worldwide are looking at a battery-based or a hydrogen fuel cell-based locomotives in areas or small pockets or smaller geographies or terrains where there is some good charging available, or let's say for hydrogen use cases, there's some refilling stations available. Such an infrastructure is available or can be made available.
That sounds good, if you live somewhere with the right infrastructure.
The other more practical option is to retrofit the existing locomotives and supplement the current diesel fuel with a battery or a hydrogen-based energy system, which makes them hybrid. At the same time, they can still significantly reduce the carbon dioxide and particulate emissions they'll end up putting out to the environment.
Okay, that's a couple of good options. So how can we get those wheels turning?
The good news is, irrespective of whichever new propulsion method our customers would take here, Bernardo, Dassault Systèmes virtual twin experiences can support their journey, irrespective of if they're doing advanced simulation, analysis, planning, or optimization. So we can go across a rail freight segment's entire life cycle, be it in the design area, the manufacturing department, or they are into automation of their networks. Maybe they want to solve their supply chain challenges and optimize their supply chain. Some of these rail operators are heavily using intermodal type of automation. Intermodal is a type of method where the same containers, the same good goes from sea to rail to land and vice versa. They also have to deal with last mile delivery in some other cases. Anyway, if you want to look at the entire life cycle, whether it's 1D, 2D, today the new energy modeling BC is solved through 2D a solution called CATIA Daimola in our platform, or even full-blown 3D. Our unified 3D experience platform houses all these solutions in under one roof, and they can go from new energy modeling to aerodynamic modeling, aerodynamic analysis to rail derailment analysis, or deeper hydrogen-based fuel cell analysis. And all those results can be plugged back into the platform, and further optimization of these alternate energy systems can be evaluated.
Wow, the sustainability benefits here seem amazing. And not just for rail, but for all transport, right?
The greener solutions that we talked about thus far for the rail freight segment can save us anywhere between 150 to 200 million metric tons of carbon dioxide emissions that go out globally.
Whoa.
And just for numbers, I was recently reading an MIT Climate Portal's analysis, where clearly they were listing rail as maybe contributing around 170 million metric tons of carbon dioxide emissions. At the same time, like you mentioned, the other modes of transport, there are various types of freight that emit carbon dioxide, and they are not necessarily the ones that are carrying majority of cargo. Let me explain that a little bit better. For example, sea freight almost carries 9 times more cargo than rail. And for that amount, they still emit significantly less carbon dioxide. Just for number comparison, rail we saw just 170 million metric tons, and sea freight, in spite of transporting 9 times more, they emit around 650 million metric tons.
So let me get that straight. That's 4 times the CO2, but about 9 times the volume of freight?
But the point being, using our virtual twin-based new energy modeling solution, same ideas can be applied to sea freight as well. So today, if you go around the globe, there are alternate propulsion methods the sea freight operators are evaluating. They are looking at wind-assisted propulsion. They want to use green ammonia as a fuel they can use to supplement or even replace their current fuel systems. Of course, they also want to deploy green hydrogen. And the classical, of course, the new energy-based, battery-based ideas are always been they're evaluating, and they already are piloting or using. Not so far in the future, they could be piloting or testing nuclear energy-based SMRs, as they call small modular reactors, can be utilized in sea freight as well. So idea being, it could be any kind of these new energies. Our new energy modeling solutions can help these operators, both rail freight and sea freight alike, to do multiple what-if scenarios of these energy models.
What kind of things would they test for?
How do they, for a rail freight case, how do my rail constants perform when I go up the hill versus down the hill? What kind of battery state of charge it'll retain under various terrains? What will be the carbon dioxide and particulate matter emissions coming from each one of the models that I want to study, etc., etc. All these studies can be done, and these kind of studies can help study, forecast, and achieve for the rail freight. I'm going back to them. They can achieve up to 30% reduction in their operators' energy expenses, which typically comes from diesel usage alone. And this is almost 14 to 20% of their overall operational costs. So when we say substantial, yes, we could really impact it substantially. And additionally, one other piece of information, they can also collaborate with their suppliers, their original equipment manufacturers, when it comes to supplying the alternate energy systems and locomotives and subsystems to them. Now they can do some meaningful collaborative exercises. So to sum it all up, we know around 80% of global goods today are moved either by sea or by rail. If you just leave aside the other 20%, which mainly come from road and a little bit by air transport, which both of them are polluting, but even if we leave them aside for now, we have this power and capability to influence almost 80% of the goods that move around the globe today, and have our customers weigh the benefits of, is it a new energy or a hybrid system that makes sense for my operations.
Wow, that's amazing. I'll certainly be thinking about this next time I use the train. Thanks so much for coming on and sharing with us today, Muthu.
It was really lovely talking to you, Bernardo. Thank you so much.
Anyway, back to you, Yanni.
Thank you, Bernardo and Muthu, for that insightful conversation. Tune in to Disruptors Unleashed if you'd like to hear from other infrastructures on the biggest challenges impacting our infrastructure and cities. Till next time. Disruptors Unleashed is produced by Dassault Systèmes. For more episodes, follow us on Apple Podcasts, Spotify, Deezer, or your nearest audio streaming platform. To learn more about Dassault Systèmes, visit us at 3ds.com.